Plate tectonics. This is going to go along with the worksheet, and you are going to write the stuff that is highlighted in yellow. So our essential question is, what are the different plate boundaries and how do they cause changes to the Earth's surface? What moves the plates? The crust is the hard, rigid, thinnest surface layer. Continental crust is land, and oceanic crust is the ocean floor. The mantle is the layer below the crust. The lithosphere is where the magma meets the crust. The asthenosphere is hot magma. It's plastic-like, so it's easy to move. And convection currents in the magma in this layer make the plates move. So convection currents are just like if you think about a lava lamp. At the bottom of the lava lamp, there's a light bulb, and there's usually a metal ring in the bottom of the glass container. That metal ring gets heated up, and it heats up the stuff inside the lava lamp, either the oil or the wax. When the wax or oil gets heated, it becomes less dense, and it rises to the top. When it's at the top, it cools, it becomes more dense, and it sinks down to the bottom where it gets heated up again, and it goes around in a cycle until the heat is taken away from it. So until you turn the light bulb off. Earth's layers. Outer core is the hot liquid layer that surrounds the inner core. It's made of iron and nickel. The inner core is hot, it is solid, and it's the very dense center of the planet. Has really high pressure. With the high pressure, it's causing it to be solid. It's made of iron and nickel. And we know that the Earth has a solid core because of the way that seismic waves move. When the seismic waves go through Earth, they don't go straight from one side to the other side of Earth. They actually hit off the core and go in a different direction. What is plate tectonics? The theory of plate tectonics states that Earth's crust is broken into a dozen plates that are moving relative to one another as they ride atop the hot plastic-like mantle. The entire Earth's surface is continually shifting. Continental is one type of convergent boundary where two continental plates collide. The results are mountain building and earthquakes. Examples are the Himalayan and Appalachian mountains. Another type of convergent boundary is continental oceanic. That is, one continental and one oceanic plate meet, and the more dense oceanic plate gets pushed under by subduction, the continental plate. Examples are the Ring of Fire, and it results in volcanoes and earthquakes. On your paper, where the results are, it says results blank islands. I need you to cross that islands out. So the result are volcanoes and earthquakes. The last part, oceanic. I completely missed this on your worksheet, so you're going to have to write it at the bottom where there's that blank space. So oceanic crust is where two crusts meet. The denser plate gets pushed under the other, and the results are volcanic islands and earthquakes. So again, you're writing this at the bottom. This one, we're not writing anything, we're just reading it. Convergent plate boundaries examples. Each red dot is an active volcano, and the Pacific plate is slipping under the Eurasian, North American, and Indo-Australian plates. Divergent boundary is where tectonic plates are moving away from each other. I just think about the movie Divergent, how they separated all those people into different groups. They divided them. The magma rises and new crust is added. Results in mid-ocean ridges in underwater volcanoes. Again, there's a typo on that worksheet there where it says results. It says blank islands, cross out the islands because the results are the mid-ocean ridges and underwater volcanoes. Transform boundaries are where two plates move or rub against each other in the opposite directions. This creates pressure that is released with the plates when the plates move suddenly, and the results are earthquakes. Example is San Andreas Fault along the California coast. Modeling plate movements. Use your hands and model a convergent boundary. So convergent should be coming together. Use your hands and model a divergent boundary. That's where your hands should be moving apart. And a transform boundary would be one hand sliding past the other one in opposite directions. What you're going to do now is you're going to answer the questions on the other part of the worksheet that has draw arrows to represent the movement of plate boundaries. Question 2 says, what is causing the tectonic plates to move? 3 says, place an X in the box that matches the event with the plate boundary. 4 is what event that changed the Earth's surface take place slowly. 5, what event that changes Earth's surface takes place rapidly. 6 says the supercontinent Pangaea covered the Earth's surface hundreds of millions of years ago. What caused Pangaea to break up into the plates we know today? If you have the paper in front of you, you are going to open it up to the inside. And I want you to number 1 through 4 on the left. And you're going to go through these 4 multiple choice questions. Just write the letter. You don't have to write the question. So there's 1, 2, 3, and 4. You'll have to go back, pause the video, and read them. And then on the right-hand side of your paper, I want you to put what are the different plate boundaries and how do they cause changes to the Earth's surface. If you are doing this from home and you do not have the worksheet, just do it at the bottom of the page.